86% cheaper. That's what Cursor is claiming with Composer 2 and their brand new in-house coding model that just dropped today. So this is basically trained exclusively on code. And the co-founder literally said that this won't do your taxes and won't write poems. And they're saying that basically this beats Opus 4.6 on coding benchmarks, but it still trails GPT 5.4 on Terminal Bench. And then people on X are actually like erupting right now. And they're going back and forth on whether like these benchmarks are legit. And because Cursor only posted their own internal benchmark and not the third party one and so forth. And so there's a lot of information that's are going back and forth, and people are talking about like these different chart crimes and stuff because they're saying, well, if you have an x-axis on higher costs here, lower costs here, and if you know me in my streams, I'm not here to like bring drama or anything. I'm just here to get down into the real sauce of things. And today we're just going to be going into a lot of building. And so I want to go ahead and take a look at these models. Is it as good as Opus 4.6 in our day-to-day use? If so, that could be a huge unlock for our pricing. Is it as good as GPT 5.4? Maybe, maybe not. We'll see. I mean, I think it's going to be really good to try to give it a task. I actually entered in a hackathon today because I was participating in NVIDIA's GTC, and I made this app called TruthLens, and I mostly use Opus to plan it, and a lot of Opus fast, thanks to Cursor's research credits, to help me like actually get up to speed, because this is like the world's fastest hackathon. So I had to do everything in 2 hours, plan, build, and everything. And so this would actually take a real-time transcription and listen to everything and actually do like chunk out things that I'm saying and actually rate if I'm like actually lying or not, in essence. And after a little while, what it does is actually does some research in real time using these various services. So it actually underneath the hood will use the Parakeet model from NVIDIA. So that's going to like set up this little WebSocket connection and do some other cool stuff. And that's how I'm able to do the real-time transcription. And then when it does the real-time transcription, I use the Tavili API underneath the hood to see if like, basically if people are lying or not. And I want to have this as an app for myself because especially with my AI agents, I can basically enable this to be a CLI as a feature. And then as I'm into different things, my OpenClaw, whatever, can actually text me saying, hey, whatever you're listening to, this person's lying, and this is why. So this is kind of like the internal dashboard. But I basically built this in about an hour and a half or like 90 minutes or so. And I have the plan, and we're going to go over it, and we're going to try to see, can we actually just rebuild this if we get a plan from Opus? It's really important to spend a lot of time planning and kind of front loading that type of information there, because I have a pretty good architecture plan for that. It took me about 15 to 20 minutes to build for the hackathon, and then the rest of it was just literally just slamming the fastest model I possibly can on it. So this is going to be a really fun build here today that we're going to go ahead and try to see if I can rebuild this, and then I can actually do a little bit of a demo live for showing you how this, because this is actually deployed right now on Vercel. So like if I take a text from like Mark Andreessen, I do like some analytics, basically what it would do is kind of do this little chunking live. And then this is kind of what you're seeing here. So as it's doing the chunking live, it's hitting the NVIDIA endpoints, and it's basically just flagging like claims when people say stuff without any sources or say some stuff that's pretty much unspecified. And then it'll do a second level 2 analysis. And that's the one that after so many chunks, then I'll try to see if I can do some research online and check for their sources and different claims that people are saying. So that's how we're able to get a sense of like the sentiment in terms of how truthful it is. And then we have a trust trajectory that's also created. So yeah, this is cool. I created this in less than 2 hours today at the NVIDIA Hackathon using the Nebius endpoints as well. So this is a pretty fire one. So this is going to be a fun build. Also, Cursor announced today this thing called Glass. And so this is a new interface, and we're going to go ahead and see, because I actually have early access to this. So this is something that we're going to go ahead and check out here and see if we can actually try it now, because that could be really fun to build with as well. So let's go ahead and take a look here. Big shout outs first. Let's go do a quick roll call. Divis, how's it going? Welcome. Tech friend, welcome. Appreciate you on the chat as well. We also have Chris Loggins. Welcome. We got Centidroid. Okay. How does the lie detection work for fact checking? It uses the model. And so the model, it does like a technical level of things. And I'll see if I can actually break this down. Lock in, bro. Why does some of the analysis on political speeches using inversion? Oh, yeah. Similar, but I have taken this to the next, but you have taken this to the next level. Yeah, it's funny because I only did this actually in in a hackathon in like a couple of hours, but I actually have a much more extensive prompt that I actually want to put in. So yeah, we're going to do a lot of building today. I only have like a quick hour, so I'm going to make sure I get through everything. The topics are down below. So if you get lost a little bit, if you're just coming into the chat or new people are coming in, they're trying to figure out what's going on, this is kind of what we're talking about, Cursor. And down below, we're going to talk about the model. We have what's it look like versus Opus, and kind of doing this whole thing with live coding. So hopefully that can follow along. We're trying this new format here. We're kind of doing it like radio show style. So let's go ahead and cook. Let's see if we try now. Ooh, is this the new? Okay, let's go. So, all right. So this is the new interface from Cursor. You can see it's like a separate type of thing. It's called I guess it's a new Glass UI. And I don't know if you've ever used the Codex UI, they now basically put together all the projects here on the left-hand side. And so it looks like you can now like basically take a look at your projects. And so if you work with multiple projects in Cursor, the most annoying thing is having all these different windows open and then having those things spread across everywhere. And so that kind of, it gets pretty annoying when you're trying to like find stuff and do different things here. So now we basically have just one unified place with a chat window. And then looks like we can also now bring in like the web browser, the terminal, and then like actually diff our changes and stuff, which is pretty cool. So like this was my last chat for the hackathon. These were some UI adjustments I was doing when I was actually like giving it some feedback and some screenshots during the hackathon. And we can actually see, like what I was doing, because I was basically trying to wrap everything up here. And then like make little series of demos. So this is pretty cool. And this is kind of like a fun little way to see then your files. When you're coding here, you can kind of see what's going on. And so in here, we actually have the app, we have the different APIs. So I have like an analytics one. This basically does the level 3 analytics. And this is mostly focused on, obviously not in the code review sense, but this is more focused on driving agentic UIs and stuff like that. So we can basically hit a new tab and hit a new output view or something like that. This is pretty cool. I actually had some early access to this, but given all the stuff that was going on with GTC, I didn't really get to play around with this. So we're kind of sort of looking at this live in real time. And so this is sort of like my first look, just like yours, in the alpha sense, because I just did some brief feedback at the very, very beginning, maybe a couple weeks ago. So a lot of this UI has actually changed since I've used it, but also wanted to give you a heads up that I did have early access to some of this stuff. And I also got to play around a little bit with the composer model, but I try to like limit myself. I just give some initial feedback and then really kind of reserve some of the stuff for the live things, but mostly because I was just really, really busy. So just as a heads up so that you guys have a sense of kind of where I'm coming from and kind of where this stuff is at. So yeah, I think without further ado, let me go back and just show you really quickly, since I know how to navigate this UI, like what my original actual thing came up with. So this was the architecture here that I used. And let me go ahead and get rid of this chat window. And so let me make this probably a little bit bigger so y'all can see here, and then kind of get rid of this thing on the side. Okay. So this is the architecture diagram. I'm going to go ahead and dump this inside of my Discord. So if you're not in my Discord, you can go ahead and sign up to get in there. And that way, if you want to build this exact thing for yourself, you can build it yourself right now. And you can probably build it alongside with me and kind of do some comparisons. So what TruthLens is, it's a real-time claim analysis powered by Nematron 3 Super. This is the new NVIDIA like supermodel that's open source, right? And so, or it's an open model with open weights. So people consume content like podcasts, pitches, and articles, but they don't have a way to evaluate claims in real time. So by the time that something like sounds wrong, the speaker has moved on. And so I don't know about you, when I listen to Mark Andreessen and some of these people who speak really, really fast, they sometimes, especially if they're experts on a topic, I don't have time to think through exactly what they said before they're already shoving in 4 more topics on top of me. I'm like still kind of processing that other one, right? And they're like, wait, that thing kind of sounded wrong, but they're already like 4 more topics ahead of me. So this was kind of my way to see if I can actually, make something that can actually do this type of analysis in real time. And because of where we're at with all these models now, and with NVIDIA's Parakeet thing that can do real-time transcription, I thought about this from my experience at the hackathon with robots earlier this week on Sunday, where robots have a latency for doing certain tasks. So there are certain things that you want to be done instantly, and there's other things that you want that can be done for the periods of time. They call that like level 1, level 2 types of thinking. And so the way that I'm thinking about that principle that I applied here is that level 1 thinking is that really fast, let's just get those pieces of chunks and figure out if people are saying something that just sounds wrong or not. And then the second part of it is like, let's collect those pieces of chunks And that's, a transcript that's like could be possibly like a paragraph, and then go send that up for analysis and come back down. And so I'll show you what that prompt looks like as well. And then the third level task is once we have the full thing, the cool thing about the Nematron model is it's a 1 million token context window. And so it's not going to cost you that much. It probably costs you maybe less than $1 or so. And then you get about 100 to 400 tokens per second on the, what's it called, the Nebius token factory. So that's something that I found out recently about the hackathon, is that they're hosting the model, the Nebius folks, through Token Factory. And that's basically super fast. And so through the hackathon, I got $100 in credits, and I haven't even burned through like $1 yet. It's kind of crazy how much prompting that you can do to get like using that model that's open source and open weight, which is, I think, really, really cool. So yeah, this is the fun project. Let me go ahead and see if I can put this and just kind of giving you a heads up. So the stack we're using is Next.js AI SDK as well. And then we're going to use Nematron 3 Super. And then we're going to use the search is Tavili. This is another one I found out that Nebius just recently purchased, but it's supposed to be good with agentic search. I don't know yet, and I want to compare this with Exa because I use Exa a lot. So this is a new part of the stack that I use today, and we're going to kind of check this out. So we have the mic here that goes to the chunker router. All of this was done through Opus. So Opus kind of helped me with some back and forth conversation, generate this entire architecture plan. And so this is kind of why I, kind of ended up with this here. So this is kind of what the API wiring is going to look like with the AI SDK. What's nice, it creates this little thing here that basically says we're going to do an OpenAI compatible endpoint, and then we point the base URL at the name with Nebius and kind of do our thing here. This is actually an out-of-date pattern with a new AI SDK, and this will be an interesting thing. Will the Composer 2 pick up this out-of-date pattern and use the tools that it has available, like Exa, like Ref Tools, to see if it can update that pattern? So I want to see some failures in round trip back, because already in our plan, there's something that's interesting that's in here that should trip it up, and we should be able to see it when it does like some type of failure run. So we're going to see how well does Composer 2 take a look at this type of code here and say, this doesn't look right. Or is it just going to be like gaslight me, right? Like we'll see. This is going to be a really fun test. And this is kind of why I'm breaking this down a little bit more and going through the details before we kind of get into the rest of the code here. So, okay, cool. So we have the design language. So what's really funny, I was inspired by the Factory AI UI, and this is kind of why it's going to be making it this way. I gave it some screenshots and said, like, let's just go ahead and build this cool thing because it's really, really cool. And here's some condensed versions of the prompts that it's going to be doing. So it's going to basically be doing these types of things here, and the level 2 prompt, and here's the level 3 prompt. So these are the different like patterns that we're going to use here. And this is kind of the demo script with our dependencies. It's a somewhat simple, lightweight app, but let me just go ahead and get this out to my folks in the Discord so that you can start building with this. So let me put Discord, and then I think I'm just going to pop this into the live stream Hangout if you're hanging out there. Let me go ahead and do this here. Let's see, I should just be able to drop it in like this. Let me just go and let's see, reveal in Finder. Okay, cool. So I'm going to drop this in here. Here is the arch plan we are building at here. And so for those folks who are currently in the Discord, you'll see this. You can actually grab this and start to build along with me if you want to go ahead and do that. Okay, cool. Awesome. Okay. Cool. Yeah, I'll catch up to the comments in a bit. I just want to make sure we kick this off and get this going because we want to see the speed. Okay. So in this type of thing, what I'm going to go ahead and do is I'm going to go ahead and hit create. I'm going to go to the terminal real quick. So in here, cd ... and we're going to do mkdir -p, and I'm going to call this one TruthLens -composer 2. Okay. And then we're going to do cursor composer. Let's see, TruthLens -composer 2. Okay, cool. So now it's going to open up a new window. And then what I'm going to do here is I'm going to grab this architecture plan and just pop it into this little thing here. And so that way we have this architecture plan we have here. And then what I might do is get the latest version and try to see if we can, because I also have a plan for this. Let me just kind of show you real quick and kind of minimize this so that way it's actually readable a little bit more. So once I have this architecture plan, the next thing I typically do is I typically just go into cursor in plan mode and then I tell it like, here is my architecture plan. Please help me put this out in phases so I can build this type of thing. But a lot of the times, especially with something like this, it's so lightweight that I didn't think I really had to do that until I had to do like a UX overhaul. So what I might do now is, since I already have the code built, I'm just really curious to see, now that I've settled on the final form, let's go ahead and see if I can make a V2 of the architecture, because I've settled on a bunch of changes and I iterated super fast since I originally built it. So in here, I'm just going to go quickly to, instead of auto, I'm going to turn off auto, and I'm going to do Opus 4.6. Edit. Cool. So let me go ahead and check out these models. So, oh, switch to glass window. That's pretty cool. All right, let me get rid of some of these things here. Okay, let's go to the models. Actually, it's kind of hard to see. Let me just switch it back to this. Okay, so models, Opus. Okay, fast. Add custom models. Let me see here. View all models. Okay. Opus 4.6. Oh, that's interesting. A lot of my models and stuff got reset. Huh. I wonder why. That's strange. Okay. That's okay. Add custom models. Cancel. Okay. Max. Codex. 4. GPT 5.4. Okay. Cool. Awesome. GPT 5.4 mini, Grok 420. Oh, that's cool. I didn't know we had that. Okay, cool. Awesome. Opus. All right. So I think what I was going to do here was, in this type of thing, pop into a new chat, and yeah, okay. So this is, I just updated to the latest thing, so that's why it's kind of all freaking out here. So, okay. Opus 4.6 high. Okay, max mode. Okay, perfect. So what I think I might do here is, please give me the updated, and make a new V2 doc for this, since we've shipped our latest version, and the arch has changed a little bit. Okay. So the goal here is to, I'm giving Cursor this prompt so that it can search through our code in our app right now. And I'm going to just give this, I'm really curious to see how Opus 4.6 performs for this task for searching. And I'm going to see if it can actually do this. Plus, I'm also going to turn this over to Composer 2 fast. Okay. And so we're going to watch Composer 2 and Cursor, Opus 4.6 high perform basically the same task. So as we're seeing this right now, if I were to, can I pop this out? Move to primary sidebar, move to panel. If I move this to a panel, can I, no, I don't see it in the panel. Okay, I think I'm confusing it with these types of things. Composer 2, okay. Move to open as editor. Yeah, I think I'm just going to leave this here. And then I'll leave this, I'll just have this go here at the same time. So here's Composer 2. And so Composer 2 is basically doing the same task, what feels like at lightning speed. And so Composer 2 is like Cursor's own model that they basically trained in their own, they have a training environment that they've set up. They've also talked a little bit about how they trained Composer 1. So Composer 1, I think, was trained using the custom kernels, and they changed the actual hardware from Hopper to Blackwell. So that's like the latest stuff that is offered by NVIDIA. And so they were able to use the new, I think it's FP8 architecture. So they're able to get super fast speeds, but they also have like a custom training environment. And so what ends up doing, like they basically have all these queries that you would normally ask as users for questions about your code. And that's kind of the environment that they're doing to go look up stuff. So not only do they index stuff, you know, in that way, but they also index stuff via the way that most users will probably use it in the environment. Plus they have all this training data that they have as well. It's just kind of from, the stuff that I've been able to deduce from what I've been able to see from their things here. So this is already done, and we're still waiting for Opus. So this is Opus's attempt, and then I don't know if they're actually the same docs. I think they're maybe the same docs. Let's see. Okay, let's see if I can do this here. Okay. Yeah, I'm catching up a little bit on the chat right now. I'm a little bit behind. Okay. Enjoying the factory agents. Oh, yeah. If you guys got to try that droid thing, that's pretty cool, right? Have you tried the Minimax Plan 2.7? I have not tried that yet. Okay, for good high volume stuff. 30K per 5-hour window? Are you serious? Dude, that's a small limit. You mean it's like the actual request or tokens? Yeah, the UI is crazy, right? With the terminal. Oh yeah, Minimax. Yes. Yeah. I'm curious to see what that would look like too, right? Like a Minimax type of thing. Yeah. So M2.7 just released. What are your thoughts compared to the other models and the Anthropic ones? I haven't really had a chance to play with it. To be honest, I've been mostly at the NVIDIA conference. So yeah, that's what's up. Although missions are slow, yeah. 20 millions per minute. Okay, got it. Yeah, what's up, Ian Dan? How's it going, man? I appreciate everyone being here. This is like the really like hot topic right now on X. So we're testing it out for ourselves, trying to see what this architecture stuff looks like. So I think our paths were crossed. So I should have probably just told it to rename it to V2. I think it overrode itself. Okay, I should have just said, oh, okay, here's what was delivered. Okay, so it updated itself. Okay. Oh, okay. I should have probably just waited. Okay, I totally cross paths, cross streams. V2, I should say V2 Opus. Okay, let me just do that again. I'm going to do that again. Continue and revert. And then we're going to do this, make a new V2 Composer doc. Okay, we're going to try the same thing again. That way they don't overwrite themselves. Yeah, I just reverted everything, I think. Yeah, okay. Perfect. Yes. What up? What's going on? Okay. So we're taking a look right now at Opus 4.6 and Composer 2. And I already have this app that I made for the hackathon. And now we're basically going back and trying to update the original architecture document. I'm having Opus update 1. I'm having Composer 2 update 1. And, since the code is already complete, this is an interesting test. We're basically going to see, is it capable enough to go and scrape through the code? And so this is going to test Cursor's actual like harness / agents at doing that when it's using Opus 4.6 and also when it's using, Composer 2. So it's only testing it within itself. And so that's probably like the closest benchmark that we have to what they've originally published, right? Because they're saying that within their own benchmarks of how they use Composer 2, it should technically outperform it at a higher percentage of the time. And so we're just saying, okay, this is a task that I normally would do anyways, like that I would give to Opus 4.6, with 1 million token context window. And then we're going to see like what's going to happen over here as well. So with this type of thing. So Composer finished pretty fast. It basically tried to update the architecture doc here as the living document, and then adding a crosslink in V2. Okay, I should have probably kind of, I don't know what happened here. Oh, wow. The Opus 4.6 has output quite an extensive report for the entire thing here. That is crazy. Wow. Wow. Yeah, Opus 4.6 is very thorough. Dang. Okay. Wow. This is, and it's still going. That's interesting. And so over here in the rewriting the architecture docs, this is the document that we originally had, and it just updated that, which was cool. And then it did some more thinking. And then what's interesting is it didn't spin off any sub-agents. So in the Opus request, what it did was that it spun off a sub-agent. And so the sub-agent that is spun off is this one here. And I'll have to check with the Cursor team because it says Composer 1.5, but as I understand, the sub-agents that are spun off are usually from the originating model. And this actually asked a question. So the question that it asked in the sub-agent request was thoroughly explore the codebase at this specific directory. And I need a comprehensive picture of the current state of the codebase for updating architecture documentation. So please provide all of this. Focus especially on the line differences on, this type of thing. And so this, let me see if I can make it a little bit smaller so that I can actually get the whole thing in the window. Does it let me do anything? Okay, let's see if we can go back. So, okay. So, okay, here we are. We kind of captured everything a little bit more. It's kind of harder to see, but I'll put it back up for y'all. So this is a request that Opus sent off to the sub-agent, and there's quite a bit of information that it captured to send off to that. And what was crazy about that request was, let me see if I can kind of minimize this. Oh no, okay. Let me go back. Okay, here. What's crazy about that request, as we can see here, as it searched through 31 files using Opus 4.6, and it did like 2 different searches. And with each of these searches, not only did it read all those files, but then like came up with the full directory tree, the package JSON. It was extremely extensive, which I found to be very, very impressive for a sub-agent task. And so once it had all this information, it relayed some information back to the other agent up above and says, now I have a thorough understanding of this code base. And after having a thorough understanding of the code base, now it's actually able to go in and update the architecture documents. That's all from Opus 4.6 using the million token context window. And this is then it creates that updated architecture doc here. So the interesting part of Composer 2 here is that while it did a search, it just looked for the existing documentation, architecture documentations that I had. And I think it it just looked for those, and it verified the code base against the documentations. And then it says it rewrited the corrupted MD to a clean living spec with Composer 2 as the dated snapshot. So this is basically what it rewrote here. And then basically it kind of looks similar to that sub-agent request. And then Composer 2 then wrote out another updated architecture document. So we can go to preview and kind of take a look here. It looks a little bit like sparse and stuff compared to the original one that we got from Opus, to be honest. And now it kind of gave me this report here. And so as far as like the outputs that I got from what I requested, it says, so now we have this architecture doc and this is what it is. So this is like the status of what it is. So like the living document that tracks the repo day-to-day is here. A newer frozen pass with code verified orchestration detail is here. So this is like this basically code pass. This looks somewhat similar to the one that we saw Opus do as far as like a sub-agent task. So it kind of split it apart. Right now, the vibe for me, I would take Opus 4.6 in this type of research task of looking through my code base to grab all the information. It just seemed to be much more thorough in terms of the research that it was doing to grab the information and the subsequent tool calls. Because we saw how many files that it went to go grab from Composer 2 to Opus 4.6, right? So Opus 4.6 explored a lot of files, right? So it went through and just went crazy with all the files, right? So this is, Opus 4.6. And then it just went ham. It was crazy. And it like thought some more and did a lot of thinking about what it touched and all the files and everything. And then it continued. It's like, okay, let me go ahead and grab some more. Let me take a look at your routes. What are you doing with your routes? Let me think some more. You know, these tool callings are very, very, very involved, right? Like there's a lot going on. And then it created like a new architecture for Opus, right? So let's take a look at this architecture doc. And so this is the executive summary. It looks very similar as far as output to the Composer one. And so here's the diagram, which I like. I love diagrams for my outputs. And if there's any feedback, I'd probably love this type of output more often in Composer because this is like the thing that I tend to lean on as a human who reviews the architecture. Because architecture is really important in terms of like trying to figure out what is your app doing and what specific details do I need to work on, and then divvy out as far as phases. That gives my gut check of like, this feature sounds like it's too big. Maybe I should cut it, or maybe I should spend more time on this feature because this is going to require more detail or something like that. So that's kind of is what it is. I like this new V2 pattern here, and this looks really, really good. Okay, so I think, yeah, it even has like design language. That's pretty amazing. Holy smokes. Okay, yeah, this is from Opus 4.6. Very, very detailed. Wow. Wow. See, this type of document is something that I can nicely, like easily hand off to the next agent, and that'll be super helpful here. Whoa. Okay. Cool. End of the architecture v2 Opus. Okay. So if I were to hand this off to a brand new engineer and a new project agent and so forth, what are the other things that I should include into this document so that they will know what to work with? And if there are any other files I should bring over as well, that could be very helpful for them to reference. It looks like the rhetorical analyzer skill could be helpful here. And then I'm going to drag this thing here. Okay. This looks cool. So this is the Opus one. All right. Am I still in Hawaii? No, I'm in California. What do you take with you when you travel back and forth? Usually my lights, my camera, lights, camera, action, microphone, pretty much this whole setup except for my desk and except for my little Apple 10-year plaque award. It's like super heavy. And I also carry this book. This book kind of goes with me everywhere. This is my thing. This is my vibe. If you guys haven't seen this is like the coolest thing ever. So this is literally like a lamp and it opens up. It's so cool. And then it has a magnet. So like it actually, you can put it on the side and then you can just put it on like outside and have cocktails and stuff. I want to make one and probably sell one to my, so you can have it, but it's a fire lamp. Like you could just have this right here. It's a vibe. But yeah, I mean, yeah, I think that I should like make my own. I actually found this at the MoMA. It's super expensive, but it's been worth every penny that I bought. And then I got this desk probably about 10 years ago plus when I first started working at Apple. Yeah, I guess it was like 13 years ago. Dang. Yeah, it's a long time. And then somebody was asking about this. This is like actually like a acrylic thing, and I'll link it in the video. It'll be I think in a previous live stream that I have. I now can link it because somebody sells it now on Etsy, so I'll link that one so you can buy that. It's like, I don't know, like 30, 40 bucks or something like that, but it's awesome. It holds my phone. It's really, really cool. Yeah, this is the vibes that we have here. 25 Amazon, let's go. So what early impressions? Early impressions, first task right now is basically I'm just doing code searching and trying to update plans. I definitely would still use Opus. Opus did a lot of tool calling on my files and like really tried to understand everything. It was extremely thorough. I was super blown away with Opus 4.6 in terms of like trying to do that for quite some time. When we compared that to Composer 2, the output wasn't as like exciting, and so the output was just, it fell flat. One of my favorite things right now, Alex, in Opus is the fact that I get these really beautiful architecture diagrams. So that kind of helps me scope the project for, like what exactly that I should be doing and whether it's like actually useful or not or something like that, or how I should rescope things. So I always find this type of stuff super useful. And my feedback to the Composer 2 folks is like to add more Opus-y things like that, which I really like. And so I think that's what's up. Okay, cool. So Tavili, okay, demo buttons. Okay. All right, cool. So now I think we have everything. Hold on. Architecture doc. Okay, so now we have this all here and settled. Keep all. Okay. So I'm going to go into the next one and I'm going to just rebuild this. So I'm going to go back out, delete. And then I'm just going to drag this over here. And then what else? So we need disable inline, keep auto keep, enable keep auto keep. Yeah. Okay. Cool. I like that. So it just automatically keeps that on to keep hitting keep. Cool. All right. So I think we have everything we need in here. So I think with this plan, I'm just going to kick off this with Composer and just let it do its thing. I want to see how it goes from zero, a really good plan, whether this is going to work or not. So this is going to be Composer 2, and we're just literally just going to take this architecture plan that we just spelled out and for my hackathon project and try to see if we can build it from scratch. So what changed from V2? Okay. I don't think it needs it. Okay. I think I should put the original one in there. That's what it looks like. Okay. V1 architecture plan. Okay, there we go. Cool. So I'll put that in there because there are references to it. So this is the snapshot v2 composer 2. Okay. So here is the, okay, shipped composer. Okay. So I'm wanting to rebuild this app, and I want you to review these architecture plans and go ahead and start building it. And boop, and boop. Okay, cool. So we have both of these there, Composer 2 and Opus. Okay. All right. So how's it Composer 2? Wait, hold on. I have so many of these architecture documents. Yeah, I have the original architecture document, which is this one. Okay, this is not the one I want. I wanted this one. Perfect. Okay, so this is the original architecture document that I made, and this was the one that I spelled out, and then this is the updated version, which has everything I basically ended up settling on for, you know, how I did all of the design patterns and everything like that. Perfect. Cool. Perfect. Yeah, this has everything that we should have in there. Cool. Okay, and then let me just remove, shoot, okay. X and X, okay. I'm gonna grab these two over here and just drag them in here. All right, so now, so in this mode, I have 200,000 token context window. I think what I should do is probably chunk it out, because there's no way this would just build it all in one type of thing. And so I'm gonna just go in here and just go one more Opus pass. Okay. And I'm gonna just go into plan mode now. So in here, I'm just gonna go in here and say, I'm wanting you to see if you can split up this work in different phases, because now I'm gonna hand this off to the Composer 2 model, and it only has a 200,000 token context window. So each of these phases are gonna be really important to implement and verify the work that we need to do. So go ahead and organize the work in that fashion. Perfect. And go ahead and send it off. Okay, so now we're in plan mode, and okay, cool. So what I want to do now that we have this project, I'm just going to close this window here, and I'm going to go back. For those who are just joining in, basically what we have here is something called TruthLens, and TruthLens, which is pretty cool, is that it basically allows you to analyze the truth for things, and so it does it in real time. So if I just refresh the page here. You can take like a podcast or something. Like, for example, I'm going to get the I'm going to get the podcast. Like Mark Andreessen famously likes to talk really, really fast. And so what we can do is grab his podcast here, and then I'm just going to play it into the microphone, and we're going to see this thing play live. Watch, so here you go.
Over the holiday break, there's sort of that. We can. And so that, that's incredibly powerful. And I think we all, kind of, I think, assume that AI now is going to get really good at reasoning in any domain in which there are verifiable answers. And so that's going to include like many very important domains. So, like the technology feels like it's moving fast and it's going to be working really well. I think the thing that is not well understood, I think a lot of people have a lot of people in the industry have kind of what I would describe as this one-dimensional thing, which is, okay, as a result of the technology not working, AI just kind of sweeps the world and changes everything. And I think that's kind of the wrong framer. I think it's based on an incomplete understanding of the world that we live in, or the world that we've been living in for the last 80 years. And I would call out two things in particular. So one is, I think it's felt to us, like in the US and the West for the last, 30 years or 50 years, it's felt like we've been in a time of great technological change. But actually, if you look for actually evidence of that, like in statistical evidence of that, analytical evidence of that, like you basically can't find it. And in particular, economists have a way of measuring the rate of technological change in the economy that is productivity growth, which we could talk about what that means. But basically, it's sort of the mathematical expression of the impact of technology on the economy. And productivity growth for the last 50 years has actually been very low, not very high. So we all feel like it's been very high. There's been lots of technological change. What's actually happening is it's been very low. And in fact, the pace of productivity growth, like in the US, is running at like a half of what it, in my lifetime, in our lifetimes, it's been running at about a half the pace that it ran in between 1940 and 1970. And it's been running at about a third the pace that it ran between about 1870 to about 1940. And so statistically, in the US, in the West, technology progress in the economy, technology impact in the economy has actually slowed way down. And so, the AI thing is going to hit, but it's hitting an environment in which we've actually had almost no technological progress in the actual economy for a very long time. So we can talk about that. And then there's this other just incredible thing that's happening, which is the demographic collapse, right? It's sort of a Western phenomenon, an increasingly global phenomenon, which is, the rate of reproduction of the human species is in rapid decline. And, there are many countries, including the US, where, the rate of reproduction is, under 2, meaning that, many countries around the world, by the way, including China, which is a really big deal, are actually going to depopulate over the next century. And so you have this kind of precondition that says there's actually been very little technological progress happening in the world, and the world is going to depopulate. And so AI is going to enter a world in which those two things are true. And I think this is incredibly important because we actually need AI to work in order to get productivity growth up, which is what we need to get economic growth up. And we actually need AI to work because we're going to need, we're going to need machines to do all the jobs that we're not going to have people to do because we're literally going to depopulate. We're going to depopulate the planet over the next 100 years. And so I think the interplay of these factors is going to be much more interesting and frankly more complex than a lot of people.
That was like go crazy with me, but like there's a lot going on. There's a lot of claims that he makes, obviously, when he's speaking. And so sometimes it's really hard to keep up even just in regular mode. And so we got to see this basically streaming in real time. So this is the app that I built for the hackathon in a couple of hours. And so it gives us like an overall assessment of like mixes plausible observations with speculative leaps, while productively stagnating and demographic trends are documented. The exploration of AI necessity lacks sufficient evidence and relies on emotional framing. And so it's really interesting when someone's speaking in real time, you can kind of try to figure out like, what is it they're trying to really say, right? So like this person basically cherry picks a lot and focuses on productivity growth as a sole measure of technological impact while ignoring other innovation indicators such as patents, health outcomes, and digital diffusion. There's also a narrative arc, so constructs a story of perceived technological stagnation combined with demographic collapse, leading to a predicted AI-driven salvation. And then there's also like the escalation part, right? So it claims that progress from AI improving reasoning to asserting AI is essential to offset depopulation and sustain productivity. So like these are crazy claims, right? Like he's like literally saying this in a podcast to Lenny, and there's like a full transcript. So the speaker argues that despite feeling rapid technology change, actual productivity growth has stalled and populations are declining. So the AI is urgently needed to drive growth and fill labor gaps. And then so it says we must depend on AI to sustain economic growth and replace shrinking workforce. So it basically breaks down the core points. It says no concrete evidence provided in the assertions based on optimism about AI capabilities. Productivity growth has been slow over the last 50 years. So this is the claim that he makes. References the economic measured productivity growth, but there's no citations or data sources. And in many countries, including US, this is what he says, states a fact about sub-replacement fertility, but there's no specific rates, sources, or time frame data, logical reference. So these are all done here. And then he basically uses a lot of ethos. So speaks with the here, and the pathos uses alarming languages about depopulation and dystopic future to evoke fear and urgency, and frames AI as the heroic solution. And in logos, attempts a logical chain and workflow here. So that's what it is there. And so what's pretty cool is like I also have a debug flow, and I can show you the analysis. So these are like the rhetorical appeals that I was able to pick up from that podcast, just from us doing it live. And here's like stuff that the sources that it looked up. So Tavili basically takes the transcript and tries to figure out like, where can I find these sources? What is it? What's being said? AI is going to get really good at reasoning. So it tries to look up stuff here. Can AI really reason like humans? And tries to find those articles and see if there's anything that's supported. And then it actually maps the trajectory over time with the person speaking. And it basically starts to figure out like, these are like the different like technical analysis that are used that I would use for trying to analyze whether someone's like saying what they say is interesting, but also people can be very tactful and very good at speaking to convince you that things should be a certain way because they sound so good, right? And they speak really fast, or they're really clear at speaking. But then if you don't know a specific topic, then it could be a little overwhelming because you're still trying to keep up and process everything at the same time. So yeah, this is something that I'm trying to make that I made at a hackathon today. And we're going to basically, we're going to hand this off to Composer to build, because I was able to build this using Opus 4.6 fast. So would Perplexity be good for this? It can, but I haven't tried the API recently, so I want to understand. The reason why I tried Tavili is because the person who won the hackathon at the Nebius hackathon on Sunday used that, and he liked that because it was so fast for like the agentic return. So because this app requires like level 1, level 2, level 3 types of reasoning, in level 2, I'm able to take larger chunks and send them back and get the responses back pretty fast. So I need that fast turnaround time. And so I'm not sure how much Perplexity is going to give me and whether I have to hand that back off to the model, because all of this is driven by the Nemotron 3 super model from NVIDIA, and it's the open source. Also the Parakeet one with the gRPC, I think, the type of thing. So I'm able to stream up these chunks of the audio files, get them transcribed in real time, and do the analysis using the super model as well. So all of this is kind of using that stack. This was, it's called the Build Fast Hackathon. Let's see. Build Fast. Let's see. Hackathon. Shortest hackathon. This is this one. This is the one I participated in this morning. So I didn't win, but it's okay. Like I got to build a really cool app, like those super fast. So it was best use of the NVIDIA Nematron models, and so that was kind of like the goal there, to build something like this that would be here. So it does tool calling, does multiple agents, and basically it's real time. So it's kind of crazy, right? That you can just build stuff super fast. So yeah, that was kind of like the TruthLens thing. So yes, I did build this. I built this at a hackathon. Can I answer the hackathon? Trying to get evicted. Hey, thanks, man. I really appreciate that. Composer is really fast compared to GPT Opus. How's it going, Chunks? How's it going? Also, if you want to try to build this app, I literally dropped the specs in my Discord right now. So if you're in the Discord, I'll show you real quick. It's in the Livestream Hangout Discord. So I literally dropped the V1 specs, and that's kind of what I have here. So the V1 specs that we talked about earlier, about like the whole stack and everything you want. This is my conversation with Opus. So you have access to that here, and you can kind of use that. Let's see, that's there. Okay, cool. Yeah. Okay, so that's this guy. Okay, so yeah, and what we're gonna go ahead and do now is, now that I've showed you a demo and I had Opus basically go ahead and build our phase plan. I'm gonna go ahead and download the plan. So I had this little download icon here, and then we're also gonna check out their new UI too. So that switch to glass window. So let me go ahead and do that real quick. So this is the new glass UI type of thing, and we're working from this type of thing here. So we can get rid of this. And so what's kind of cool about this type of UI is this is like very much chat based or chat focused. And so in here, I have my other projects, so I can see them in here or not. And so if I wanted to work with like multiple projects at once, which sometimes people do, you can always reference your previous chats here, whether it's on the cloud or whether it's not. So it basically just kind of unifies everything all together. And this is part of the new UI. Let me just go ahead and hit plus again, so that way you can kind of see what's going on. And this is definitely, you can tell from up here, if you just hover over it, it shows us like what specific repo it's in and what's going on. These three little dots can open a new window, fork chat, and so forth. And so this is our plan here. And I think we already reviewed the plan. And this is our way to build with the models and stuff. So I can say Opus 4.6, show all models. Okay. Okay, cool. All right. So now that we have that here, we can hit Composer. We created our plan. And so let's just review the plan. So phase one is literally just going to be project scaffolding for the design system and the core types with Next.js 16. And then the second part is going to be the API routes. And the third part is going to be the input UI, the debug components. And the fourth part is going to be the orchestration analysis stuff. That's the complex stuff that you start to see there. And then the fifth phase is going to be the voice input with Riva. And this is the actual implementation with the gRPC. And so this is where it would receive those chunks, which I was showing you on the podcast. And that's how it's going to do the buffering and everything like that. So theoretically, we should be able to kind of cut this up into these different phases. So with this plan here, what I'm going to go ahead and do is go ahead and make sure I check all the code in. And so I'm going to initialize a repository. And so now we have all of our files, and this is a pretty clean UI there's not that many files which are here, which is really cool. And so I'm going to go ahead and just check everything else out here and have these little dots. This shows us our view, and I'm going to go ahead and commit and push. And so I don't know where it's going to push to, but we'll see. Okay, so git status waiting for input, and it's going to be like, okay. So it looks like it actually sends the stuff through command line. And so I don't know if it's going to push it to public. We'll see. Okay. Oh, inference engineering. Oh, that's right. Yeah, for those who weren't on live stream, earlier a couple days ago, I got to check out the inference engineering book. This book's so cool. Look at yeah, you can kind of see that pattern. I will read a chapter when we're waiting for some prompts and stuff, because this is a fire book and they have some really, really cool demonstrations. I'm going to be doing a giveaway this weekend. So if you stay tuned in this weekend, I'm going to give away one copy of this book. You can get this book for free via PDF. You can also buy it as well. Has an ISBN in the back. This is from Philip Kiley from Base 10. And so he did a lot of work. One of the first like 100 engineers, back in 2022, that was actually really focused on like deploying stuff as far as engineering. Why this book is really important is it's going to give us the nitty-gritty details of what is basically happening underneath the hood when we hit the API endpoints. And so whatever you're talking to these language models, we're dealing with inference, which is like the model's already trained and we're just receiving the results. So this is the engineering behind that stuff, and it's going to actually help us gain a lot of clarity. Learning the vocabulary that's in here is going to be really nice, and it breaks it down in a simpler fashion. There's even a glossary of terms that can tell us of things that we aren't aware of, and it doesn't treat you like an idiot, which is awesome. So it talks about a transformer. It says the transformer is the foundational architecture behind generative AI models. And transformers libraries as a reference implementations for LLMs and other transformers-based models. So every Sunday, I'm going to read a chapter or read something from this, and just going to continue reading through the entire book. You can follow along with me. Definitely highly suggest you check this out. Really, really cool book. And I was reading it on live stream when I got it a couple days ago. So I think it was yesterday when I got to go before I got to talk with see the talk with Jeff Dean. So thank you for the reminder, by the way. That's really cool. Yeah. Okay. Yeah, definitely a giveaway. Made my own whisper flow. Let's go. Yeah, it's really good. That's a really good model. Okay. So, no remote is configured, so there's nowhere to push yet. No push remote setup. Do you want me to create a remote repo with git push? Okay. What's really funny? I prefer the UI over here for this flow. So in the older version, when I hit publish branch, this was so easy. So I think what I'll do here is, now that we have the plan, I'm usually used to plan like reviewing plans like this. This is a really nice dependency diagram. So I hit publish branch, and it's going to bring me two options. I'm going to say publish private or public. So I'm going to do private for now. Okay. So now that we've published it, we're good. And so we have this here, and I'm curious, in the new UI, what can we do now to build this thing? So if I go review plan and view plan, I can change it from auto. I'm going to change that off to composer too fast. And then I'm just going to select this first one. Oh, wait, hold on. Wait, okay. Huh. I used to be able to select, okay, maybe this is still early access, by the way, or still early alpha. So there's a bunch of feedback that I got to send over because it looks like it reverts back to auto. So for now, this is kind of what it looks like. And I'll show you kind of what I usually do on the other side of things. If I close this out, when I start with my plans, I like to just select one of these guys and say build with new agents here. So I have the Composer 2 model selected, and then I could just say build a new agent. And what's cool about this is that it'll actually pop over to the new chat, and we're going to use Composer 2. So go ahead and do that. And so now we should be using the Composer 2 fast. And it's literally just going to take this chat. And what's nice about this UI is basically what it does is it creates a chat thing at the bottom that we can go ahead and reference. So now it's basically taking this empty repo, which only has our planning docs, and it's now just going to go ahead and create the next app for us. So we'll watch it kind of do this as. Thoughts on the model? I think the model could be very competitive to Opus 4.6. Our first task with regards to going to an existing repo and doing like a planning type of task where we need to do some research and grab some files and do some things, it fell short when compared to Opus 4.6. I felt that Opus 4.6 was much more thorough in terms of like numbers of files it read. It read like 30 plus files. It even launched a subagent with some really clear instructions to hand off to the subagents for it to do that type of task compared to Opus Composer 2 just by itself. So that's kind of an interesting first little insight there. Obviously, the stuff is going to be different, but I don't use it for planning. But it's really funny. It's not really a planning task. It was just more of a research task. It's like, hey, here's an existing plan. Can we make sure we have the latest version of the plan? And to me, it's really clear that handoff documents and handoff subtasks are going to be really important here. So let's see what's going on here. So what we're doing now is, now that we have a detailed plan, can Composer 2 take the plan that was generated from Opus and just go ham on implementing, right? Because this is just like, I want it to be my workhorse model, and I want to see if it's actually just going to be that model where it's going to identify some of the issues with the plan. There is a hidden issue that's in there that's more specific to the AI SDK. It's only specific to the AI SDK v6 version. I know like they update those things like every 2 months, but it should bump into an issue when it's making it that's like, hey, there's something that's wrong here. Let me go ahead and grab the EXA API and see if I can go ahead and do that. Or is it just going to follow the plan and whatever's written literally do that in there? So this is going to be an interesting catch to see what it can do here and kind of watch it do its thing. We're only limited to 200,000 token context windows. So I've split up my plan into phases to make sure that we're able to achieve these tasks. So as of now, the project scaffolding is up. So let's go ahead and try to see if we can build the plan. So bun install, bun dev. Don't show again. Okay. Cool. So now it's up. It's basically the app is up. It says TruthLens. That's all we got. Okay. So go ahead and yeah, this is good. And I think we have, wow, we have a lot of scaffolding up. Let me just kind of get rid of the chat real quick and get rid of this. Okay. So as of now, we have some basic libraries that are up. So we have some types that are in here. Okay. Schemas. We have the layout. Yeah, it just initiated the project using next initiated. Interesting that it self-references the agent's MD. That's interesting too. Okay. I've not seen this before. We have our original plan. We have our prompts. Okay. This is pretty cool. So I'm just going to go ahead and commit this. Updated phase 1. Commit. I'm going to push this to the server so that I have it saved in case something happens. You never know. Okay. So now let's go ahead and go back to our original plan. And so let's go back over here, go view plan. I'm going to go ahead and close the other chats as well. And then, cool. So now we're going to grab phase 2, and I'm going to go ahead and hit build new agent. So we currently have composer 2 selected. And so the next one we're going to do is actually do the API routes, because as of now, we don't have any of the API routes. We just have the app. We have the library of stuff. And so this should be able to add our route handlers and all the various things that we need to add here. So let's go ahead and do that. And hit this and hit build a new agent. Let's see what happens. It's pretty fast, right? So yeah, cool. When's the next Rate Limited podcast? Oh, we just recorded it, I think yesterday. So it should be out by this Saturday or Sunday. So be on the lookout for that. Yeah. Yeah, that's what's up. Let me see. I think I'm missing some other chats. Jesus, Chunks, what's going on? Oh, I see. $200 for the Amazon lamp. Oh, okay. Yeah. Yeah, this thing's fancy. Okay, let's see. Have I tried Pi yet? Pi is really cool. I never went back to Claude Code except if I launch my own agent team from Pi Tmux. Yeah, I think right now, to be honest, I've been spending more time inside of Cursor and Droid. And so like those are really, really good already. Pi is really cool because it gets me down a different route. But the time that I would want to spend on Pi right now is all the time that I'm using to spend on my OpenClaw, because OpenClaw uses Pi. So if I really wanted to, I can configure my own Pi stuff within that. But the most of the time that I'm configuring things, I just want to make my OpenClaw to be really, really useful. And so I keep adding features and kind of doing things there. Eventually going to come around to some things because I'm using, going to check out the Hermes model. I've been pretty behind on things because of the GTC stuff. So I'm going to get back onto things. So today's Thursday. I've been, I think, almost streaming every single day. But I try to do Thursdays plus Saturdays and Sundays for everyone. So tomorrow I'm going to take a break, a much needed break, because I've been streaming like crazy. And we'll resume normal things today, and then Saturday, Sunday would be for sure. Okay, so now I think it did everything for this Nebius thing. Wow, that's pretty fast. Okay. So now it implemented our route handlers. So we have this stuff here. That is crazy. So it did all of our levels, level 1, 2. So this is the deep search. It's pretty cool. Here's our patterns. And here's the route handler for the pulse. And here's the extraction stuff. Interesting that we're doing these fetch things. Is it using the AI SDK? Huh. Analyze. What are we using? Tavili. Okay. So we're just, okay. Huh. Oh, okay. Prompts, Nematron. So here's the base URL. Yeah, we use the AI SDK compatible, and then we build it here as like a, cool. Okay. Cool. Dang. And so what do we have here? Let's just kind of check things out. So there's no there's no example.com. So we now have our .env example. So Nebius, Tavili, NVIDIA, and ASR function. Okay, cool. So this will basically grab the ASR, the live microphone stuff. So let me go ahead and grab my keys here and see if I can do that right now. cp.envexample.local to local. Okay, perfect. So what I want to go ahead and do is put my keys up here. So what I'm going to do for now, I'm just going to go ahead and see if I can kind of type of thing, and see if I can get the keys from the other project for now, and without exposing too much information, and then put them in here so that way we can do some testing. Because yeah, I want to get this thing up and running. So let's see, TruthLens .env example. So yeah, I'm just getting the .env example stuff over so that way we can actually start cooking with this stuff. So this is the Nebius API key. Cool, got that. And then, perfect. And then I'm doing the Tavili API key. Cool, I'm gonna get that over here. Boom, okay. And then I gotta get I don't think I need this function ID thing. I think it's optional, right? Yeah, optional nim deployment. Yeah, I don't need that. Okay. I'm gonna do the NVIDIA API key, perfect. All right, cool. So that'll be nice, and then turn on auto cloaking. Perfect. Okay, perfect. Okay, cool. So we have this here, and as of now, I think I have everything set up. Turn on auto cloaking. Perfect. Okay, let me just copy something else just by accident. Okay, so folks, I think I have everything I need to reveal everything without leaking all my keys and stuff. And if I do, whatever. We could always revoke them. Okay, so I have everything here that's set up, and cool. With the valid, okay, perfect. So I've set up the keys here, and there's like a review changes thing. Okay, go ahead and check. We're just YOLO committing everything. Okay, so phase 2 is complete. Let's go back to our plan again. This thing moves really, really fast. So phase 3, we're going to build a new agent. So this is going to be the flag, the confidence meter, the transcript. Let me just kind of bun install and then bun dev just to kind of see where we're at right now. It should load something. No? Okay, it doesn't, I guess. What's going on? Why the kill? Okay. Oh, I know what's going on. There's already an existing process set up and running. Okay. Okay, so there's nothing going on in our app right now, and we're gonna come back to it. So we're almost done. Okay, sweet. Now time to build phase 3. Let's go ahead and start doing that right meow. Okay. So the reason why I'm doing these new chats is because the context window is limited inside of the Composer model. So Composer 2 has a 200,000 token context window, and we're trying to see, is Composer 2 as good as Opus 4.6? Can you make a nice big plan in Opus 4.6 and just hand that off to Composer 2? And Composer 2 is what you would probably want to do all the work to do anyways. Can it do all the tool calls that it needs to do to literally effectively use your plan and do everything you do? So for example, you can save your intelligence with Opus 4.2 or GPT-5.4 and then hand that off to a Composer model. And so what I want to see here is how good is the UI? Is the UI in Composer 2 as good as, Opus 4.6, right? Because that's the biggest gripe I have with the GPT 5.4 model is that the UIs aren't really that hot, to be honest. So if I give us some type of direction with Opus 4.6, Opus 4.6 as the intelligent brain, it analyzes the UI, understands what my requirements are, put that into a plan, and then I ship that off to a model that's way, way cheaper. Can we really cook here? So that's going to be the thing that we have here. So we're going to get some UI coming in and going to be able to check some of that stuff as well. Yo, what's going on? Nick Diaco, what's up? The community is drooling for Composer 2 on API of Cursor. So I don't know if you know this, but as it supports the agent protocol, so you can actually link this to your OpenClaw. So you can have your OpenClaw use Composer 2 and just start doing that. If you have other apps like JetBrains or I think Rebook Prompt maybe even support that, they just have to implement the ACP protocol, and then they should be able to get access to Composer too. So it's pretty damn near the API. So you get all that stuff. Is Composer 2 worth it over Opus 4.6? That's what we're trying to find out right now. Do you use Cursor because you know how to code? Probably. I haven't really had much use for it for a while personally. I think that's probably most of it is because a lot of times I spent a lot of time like coming up with these architecture documents and trying to really understand what's happening in these different places for a couple of reasons. One, I'm trying to get deeper into the code and understand what's actually happening because there's a lot of stuff I'm not familiar with. I'm not a web developer by trade. A lot of stuff I did by trade was using the actual phones for, like on-device stuff. And so cloud server things are really a newish domain for me. But lately, I've also been trying to learn how to like actually program CUDA kernels. So like actually making the GPUs go burr. So that's another side quest that I'm doing. Also working in the robotics space too recently. So that's been a really fun little venture to try to figure out like what's going on with this stuff. So I like an IDE because I want to see what's happening in the code. I want to insert little debug markers and do all kinds of cool stuff to see what's the data that's being passed through. And start inspecting things. But that's kind of what you do as an engineer. But I feel like this is kind of like a cool playground as like a good in between to do that type of stuff. So part of that is that it includes like this language server protocol type of thing. So, or language service protocol. So you can actually see, like as the code is being compiled or put together, it's going to tell you whether something's working or not, almost like right away. So I think we may have enough of a UI to bring that back up. Let's see, bun dev. Oh, cool. Nice. So this is the UI from Composer. So let's just kind of make this a little bit bigger. So you can already see. So now it should be able to get something. So if I do Andreessen, that's cool. Load sample panels. Nice. This is from Composer too. That's hot. That's pretty hot. Wow. Okay, this is pretty damn cool. Wow. Whoa. Mark Andreessen blog post. Yeah. Is it PM archive? Why not to do startup? Can it fetch this? Let's see. It didn't. I think I still got a long ways to go. Okay. Cool. So yeah, now we have some UI. Hey, this looks pretty good for Composer too. Not bad. I mean, I'd take this all day over Haiku. Can you tell me or show me your mission control and if there's a GitHub reboot for it, please? Mission control. Please let me know a little bit more. Made me want to reopen Cursor. I mean, the model I think is actually impressive for the speed, the size, and everything. I'm using the fast mode, so it's more than the cost of. So like I think it's $1.5, $1.50 per million input, and I forget what the output is. I'll look it up real quick. So yeah, that's pretty good. We have some initial UI with the pulsing stuff. Now we're gonna go to the orchestration URL and start to do some of that work. Oh, did I hit the wrong one? I did. So one thing about, oh no, okay, let me just go back here. So one of the things that you can do is I usually like to check mark it, click to select, and I hit build in new agent. So if I hit the build with new agent, it's going to open up a new chat. And that's how I'm able to keep my context window nice and small because we only have a 200,000 token context window. And that's kind of what I'm using here. So that's what's up. He means your OpenClaw mission control. I don't actually have a mission control built for my OpenClaw. All I use is Notion right now. So I basically, if I need to view anything, I just tell it to pop it into Notion and I use a Notion workspace. I thought about building a mission control, but that has been lower and lower priority that now that I've integrated Notion. And so it may come back into a little bit later, but a lot of times I'm really task oriented and I just recently created topics. So inside of Telegram, you can create topics and topics are super useful because you want to keep a conversation going. And I feel like I could have multiple conversations at once. And then if you haven't watched the recent stream, I have a video that's going to be coming out on the long-term memory stuff. That's just a plugin that you just install. And with that plugin, you can actually have long context over all of your topics, all over all of your chats over years, which is crazy, right? So it's built into OpenClaw and then you just run command and it installs it as a plugin and it'll just, with your chats and everything, you'll have everything going pretty much forever. So it's different from QMD because QMD is going to do some type of searching and stuff. And it should work, over this longer period of time. Pete Steinberger is actually the one who recommended it on Twitter on March 13th. So if you get the 3.13 update, you'll be able to see that. That also included the update with Chrome, by the way. So if you're using the Chrome browser, make sure your Chrome stuff is up to date. And your OpenClaw can control your Chrome browser via an MCP that's already built into the whole ecosystem. And it will bypass a lot of that CAPTCHA stuff. So it'll basically, the driver won't be running in headless mode. It'll be running as if you're like a user. And so it's kind of crazy. And so, yeah, I have a video coming on that very, very soon. So do I use Obsidian? No, I use Notion. Still doing same UI quirks, GPT, Claude, online dots. Yeah, I can see that. I need to give it like a better design language for that so that it would be better. I use Brave browser with the new remote debugging since it's a Chromium browser. Yeah, there's a lot of different options. So let's go ahead and bun dev. Let's see what the latest changes are. Cool. Oh, wow. This is nice. Okay. So if I paste this part in. Whoa, that was fast. Oh my gosh. Did you see how fast this was? Holy Yo, that's the blog post from here. Oh, this is sick. Yo, it chunked out the whole like blog post and it did like an analysis and now it came back with the error. Damn. What? That's crazy. Now it's waiting for analysis. So our fetching thing is working now. Damn. No, I didn't realize Tavili was that fast. Hold on, let me look up some more articles. When VCs say no. No way, bro. Because it's HTML, right? Bruh, look at that. Oh my God. Oh, wow. It chunks out the whole thing and it'll do the analysis on all the chunks. And right now it's doing the analysis. Bro, this is sick. This is wild. Oh, so now we're doing the level 1 analysis. And what do we have here? So yeah, I got a 502 on one of them. Yo, it just did. Okay, so I got to fix these errors. But this is crazy. So I didn't realize that's Tavili. Tavili. They have an extremely generous 1,000 credits per month, I think. Yeah. That's sick. That is ridiculously fast. I had no clue. This platform is really cool. Let me see if I can open up a new window. Tavili.com/home, I think. So what they do is Tavili.com. Just go to the regular. Okay, connect your AI agents to the web. This is what they do. I found about them through a hackathon. I had no clue how fast they were at extracting everything. So their whole thing is about getting the data out from these websites and extracting them to give them to your agents. Because I didn't realize how fast and how good this was. Holy smokes. So compared to Perplexity Search, has a 93%. Somebody asked about Perplexity Search, has a 93% accuracy over that. Over Google, over Brave, over Exa. For simple QA bench, right? If we do document relevance, killing it. Deep research bench. What? Latency. It is fat. Oh my, and the accuracy. So not only do you get the speed in terms of latency that beats Exa, you also get the accuracy percentage way higher. Wow, this cooks. That's why Nebius acquired them. Dang, bro. This is sick. Holy smoke. Okay, so I found a new agentic search, and this is called Tavili. I'm going to have to hit them up. They're going to have to come through the stream. They're going to have to hook everyone up with tokens. Holy smokes. It's already pretty generous as far as pricing to use because it's 1,000 free credits per month. That's massive, right? And if you just pay per use is like 0.08 cents per pay as you go. If you don't pay $30 a month, you get 4,000 credits and higher rate limits. Wow, this free for students. That's sick. Wow, that's impossible. It is impossible, right? How can Composer 2 is better than Opus 4.6? That's what we're trying to figure out right now. Tavili is amazing. Works great with OpenClaw and Hermes. I'm about to switch my OpenClaw to Tavili. I had no clue it was this good. Exa, bye Exa. Tavili's in, bro. Tavili is in. Bruh. Did you see how fast we grabbed that document and how well structured that was? I can't even comprehend. Okay, so can we grab like I'm gonna grab something. What are we gonna grab? Let's grab their composer one, right? So like this composer one that just came out, let's go ahead and just run it through Tavili, right? I'm just curious to see where we're gonna get, right? So if we go back to my app right now and go fetch. Come on, baby. Oh, it's already here, bro. It's already here. So it fetched and it was also doing the chunking. And so I have to fix this bug. My app is not completely done yet, by the way. We're still using Composer 2. So the fetch part is already done. This thing works lightning fast thanks to Tavili. And it grabs all the documents and parses it beautifully. I didn't really write any code. I have no clue what's written there, but we'll have to see. But it has like the patterns panel. Okay, we're still figuring out all this stuff. Holy smokes. Yeah, my agent's been using Tavili for a long, long time. Man, I got to get up on that, bro. That is really, really good. Holy smokes. This is good. I love the surprise and delights. You know what I mean? That's what this is all about. This is why I like to live stream, because like if you record this stuff, then it's not as exciting. You know what I mean? Like this is what it's all about. Like the authentic liveness of this. And plus you guys just chilling right now in the chat. You know what I mean? I really appreciate everyone showing up here. So let's go ahead and go back to our original plan here. So I go back to the plan. And so now we're going to be in phase 4 now. We already done with phase 4, right? Phase 4 is done. And so we're going to go back to our plan. Perfect. So yeah, we're going back to now we're going to do phase 5. So phase 4 is done. And then we're going to do build a new agent. So this is going to do the voice stuff now. So this is where I can do the real-time voice. And so it's going to go ahead and insert. It's already read the MV example stuff. It's just going to go ahead and grab everything here. Do you think if it's worthwhile for me to release my own agent, not OpenClaw? It's a minimalistic super Python. You know what? I always say, Gene, just like go ahead and release it. I think the bigger part is like get feedback as fast as possible. Make sure you get it in front of like an audience, your friends, your family, and like people who want to use it. I think that's the whole reason why Peter Steinberger releases stuff, is because his friends he showed his friends and they're like, hey, I want that. Can you give me that? And he's like, oh, you're not a developer. I don't want to basically blow up your security or anything like that. And then when he posted it on Twitter, no one cared. And so that's like I'm just going to encourage you to just put it out there. Try to get it in front of people. There'll be some people who would think it's care, or just keep iterating and keep working on it, I'd say, So that's what's up. Is it better than Parallel even? Something seemed interesting. Like I got $50 from December deals on Exa, so it's good for a while. I don't really know yet, Nick Diaco. This is kind of like my first reaction. Like I didn't realize how fast it was, because when I was in the hackathon, I was really just trying to move as fast as possible. So I nearly got everything all done at once because I had such a small period of time. So what's going on here? So it's doing some curl requests. I don't know what it's doing here. Implementing it's actually grabbing like actual files to transcribe. Nice. This is crazy. Okay, cool. I'm using agent mail. I'm agent myself instead of OpenClaw for security reason. By the way, I'm the guy who wrote the first book on Neuroevolution, Handbook of Neuro. Dude, what is the name of the book? Through Erlang back in 2013. Let's go, Gene. I want to check this out. Do you have an X handle? Is it Gene7499? Like, drop your X handle. I'll go look you up. Yep, I'll probably be your first follow, huh? What's going on X right now? Are people still blowing up? Let's see. Cursor's model. Okay. People are checking this out. Okay. Oh, man. I feel really bad right now for the folks over at Replit, because the Apple quietly blocked updates from like the vibe coding apps. So if you have a vibe coding app like Replit, I think Lovable, all these people, so you can literally use your iOS app to make apps. And like, I don't know if you can publish from them, but at least it was like super helpful. And they're just like, yo, we're just going to block you guys. Super sad. It's like, come on, man. That's super weak. It's in the Library of Congress. I do not have an X handle. Oh, what is your name? I want to look up your name. Let's see. The Handbook of Neuroevolution through Erlang. Oh, Gene Sure? Seriously? No way, bro. Doctor. Whoa, 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 whoa. How did you find my live stream? I am honored. That's crazy. You must be just as crazy as me. What? This is brilliant. With a foreword written by Joe Armstrong, this book offers an extensive tutorial for creating a state-of-art topology and weight-evolving artificial neural network tween platform. In a step-by-step format, the reader is guided from single simulated neuron to a complete system. I want to know more about this because it's funny because I was actually going to start making Erlang apps way back, like before I started doing the AI stuff, because I was super interested in that protocol. Because I was just, in these big, massive messaging systems and figuring out how they work, which can be applied to artificial life simulation, Forks trading. Oh, that's also another thing too. I was like getting really into trading because Erlang's architecture perfectly matches the evolutionary neuro computational systems such as programming languages, concurrent messaging, passing paradigm. Wow. Is there like a PDF of this book somewhere? I want to read this right now. PDF. Oh, heck yes. Allow? Oh, it's like, that's so cool. Oh my gosh. Tangents. I love these tangents. Bro, this is crazy. Joe Armstrong created the Erlang. That's amazing. I've been watching your content for a while. Oh my gosh, that's awesome, man. I'm deeply honored. This is crazy. This is crazy cool. We have some amazing folks in the building right now. Handbook of the Wow, I want to read the foreword. Let's see. I was delighted to be asked to write a foreword for Gene Scher's book on Neuroevolution. To be honest, I didn't have a clue what Neuroevolution was before I started reading this manuscript. But the more I read, the more I became engaged in the content. Gene addresses what is a fascinating problem, how we can simulate a biological system in a computer. This is what's actually really interesting to me. This is kind of why I'm sort of like midstream kind of dropping my jaw right now is because of this exact reason. And I feel like a lot of people are trying to do this with AI and these like symbolic systems and like these different ways of thinking things. Also having worked really deeply on these different OSs and stuff, at Apple, like to see how everything sort of evolved from theory to actually like practical people who made the operating systems that scale to like literally billions of people. And so this is really, really fascinating. And I want to go more into this. I just realized it's 6:46 and I need to head out for dinner soon, but I'm going to get back to this book. So between this and our inference engineering, I think this Sunday we're going to go pretty deep on some of these topics because I want to go deeper on this stuff. Like I really feel like there's a lot of really good knowledge around this right now. That's a really cool topic because this is a really cool interleave along with the inference engineering and seeing like what people are doing at scale. That's so cool. Awesome, G. Nice to meet you. Super cool. Wow. Okay. Let me kick off this next task here because we should have our real-time transcription really quick. This should be already ready to go, bun dev. Okay. So we're totally, yeah, now we have the microphone up. Transcription works because it looks like it's working, but I'm not really sure if it's working or not, but we'll see if it's working because it is working because I see the no function ID was passed to the metadata. Stop mic. Okay. Yeah, so it looks like what we're going to go ahead and do is the architecture diagram. So I'm just trying to get some of this stuff up, and here's the transcription route. It really didn't take that much lines of code to implement, to be honest. It looks like it's pretty straightforward. And then we'll probably have to fix some of the other things that it's kind of waiting for here before we head on out. So yeah, because to be continued for, I might even live stream tomorrow, even though I wasn't supposed to live stream tomorrow, just because I want to see this through to the end. And I also want to continue reading this forward here from Gene, because this looks really, really cool from Joe Armstrong to Gene. Joe Armstrong created the Erlang programming language. That's so crazy. Yeah, I know, right? I can't believe this is in the Library of Congress, bro. Ah, that's so fire, bro. This is crazy. Cracked. Super cracked, right? Yeah. Okay. So let's go ahead and check it out. So yeah, as far as Composer 2, quick thoughts before I head on out is right now it cooks. It's really, really fast. As far as UI, if you give it a good direction, if you give it a good plan from Opus, it can execute and executes pretty fast. Opus 4.6 seems to still be pretty good when I ask it to like review an existing repo and go dig through stuff. I found Opus 4.6 to be extremely thorough at not only tool calling, but also grabbing lots of files and reading different things. Granted, we are using Cursor and we are in Cursor's harness. So that's where a lot of this stuff is taking place. Cursor did their own benchmarks on their own harness and compared themselves to themselves in a way. And so that's sort of what we have as a benchmark. And that's kind of what we're doing here anyways. We're using, how are you going to be able to go very far with Composer 2? It seems very promising. As far as like using it to generate UIs, I would probably use this over GPT 5.4 all day, because then your UIs don't smell like GPT 5.4. They hit different and they smell different too, right? All right, so I think that's kind of where we are at with this. This is going to continue going. I'm going to be live tomorrow. I have to be live tomorrow. This is such a crazy topic. There's a lot going on. We're going to do some more comparisons. We're going to be coding live. We're also going to be going over the inference engineering. And then I'm going to be raffling this book on Sunday. So I have an extra copy of this book called Inference Engineering. We're going to read through some of this. I'm going to also read through that book from about the Erlang programming from Gene as well, and kind of talk a little bit about neuroevolution through Erlang back in 2013. So this is a really cool way of these are like major systems that we're working with, and there's a lot of stuff that's really going on. So this is what we have so far. We got to take a quick peek at the new UI called Glass. It's like a new window that Cursor offers here. And so this new UI is still in really early alpha release. Not everyone has access to this. There's a little bit of bugs here and there. So if you are going to use it, there's some stuff that's going on. I do have an in at Cursor, so any feedback that I get usually gets directly right to the team. So that's how I'm able to then, get that stuff over to them and get that stuff iterated as fast as possible. So all of these chats that we've been having have been going on here. So we see our current stuff here that we've got going on. I could do a review, and this gives me a review of all the different things we have for all the code that's been committed. So you can kind of see that there. They have a terminal UI. They have a browser. The browser is kind of built into here. And then we have our terminal, that will run the different projects. And so as of so far, I think it is looking for my skill file and so forth. And then this is like the little model selector stuff that we have here. So yeah, that's kind of this in a quick nutshell. We're going to have to resume this and kind of come back and fix the different errors. And so this little Truth app has been pretty fun to kind of build live with y'all. And so hopefully by the end of it, we'll have a whole thing there. If you're currently in my Discord, you can have access to this whole plan that I just published here. So this is this plan. I'll also publish the V2 for the architecture. That way you can kick off your own build yourself and see what this kind of looks like for your type of building. Because I think you'll have some really good fun. So this is a really cool app that I built at a hackathon, and try to rebuild it with Composer 2 to see how good it is. And it's going to have a more in-depth look probably tomorrow, and probably just stream all weekend just building software, because this is really, really fun. All right, y'all, got to go to dinner, and I'll catch y'all later. Peace.